Recording has started. Hello again, everyone. So today we will be studying the front-end optimization. Our agenda will consist of covering several topics, including HTML optimization, CSS optimization, image optimization, and JavaScript optimization. We will talk about different techniques that you can use, why optimization is important, how to measure it, what different strategies are there to handle optimization. So let's start from the basics. What is optimization? Front-end optimization is the process of loading your page. As we have discovered, our pages, they are nowadays they are not simple anymore. They are quite complicated. So when you are loading your page, if you open your developer tools by opening F12 and then you navigate to some modern website, you will see that in Network tab, lots and lots of things are happening. You are loading your HTML, your CSS, your JavaScript, you're loading lots and lots of images, and there can be much more than just one HTML file or one script file, and so on and so forth. And all of these processes, they take time. So front-end optimization, FIO, shortly, also known as content optimization, it means doing anything and everything in our power in order to reduce the time that it takes to load the page to give the content to our end users. Because obviously longer waiting times negatively impact the end user experience, and we would not want that. A big part of content optimization nowadays are CDNs. CDNs, or content delivery networks, is what we are currently using to deliver our content to our users. Long past are the days when we were just hosting our website on our own machine, and then we were scaling our hardware as there were more users coming to our website. Nowadays, we are mostly using cloud-based services such as Amazon provided, Google provided, and when we are using these services, we are getting access to lots and lots of optimization tools. So, for example, a typical content delivery network offers auto-file compression, auto-minification features. We will talk about what these are later down the line in this lecture. So, when you are using CDN, and like 99% of the time you will be using CDN instead of just doing everything manually. It's just not feasible nowadays, because instead of having to take lots and lots of time to do everything by hand, you can just pay to a service, to a content delivery network, and it will handle this for you. And using CDN will free you from having to manually tinker with your website resources. One of the most important metrics when measuring front-end performance is TTFB, or time to first byte. This is one of the most important, but one of the most misunderstood performance metrics. It's mostly misunderstood because there are two ways in which we can measure it. So TTFB is the duration it takes for the first data byte to arrive from a server to the requesting browser. And from a perceived load time perspective, TTFB is the duration it takes for the browser to parse the first byte after downloading the HTML file. So there are two ways of measuring it. One is the actual time. It's the shorter one of my scheme. It's the time it takes for the first byte of data to arrive from a server to the requesting browser. But when we're using this as a metric, we're usually going for the perceived time, because perceived time is longer and it is what our end user will see. So there is also a time lag between receiving the first byte of data and actually parsing it, like beginning to do something with it. So when you have just received the data, it does not mean that anything is happening yet in the end user's browser. Only when we have begun parsing it, something will happen. So we are usually using the time to first byte perceived time, the longer time to use it. Next, why performance matters, like while we are having this lecture at all. Performance really matters nowadays because based on lots and lots of inquiries, based of interviews with users, more than 57% of users abandon a site if nothing happens for 3 seconds. And I suppose you can easily trace this back to yourself. Like, for example, you're surfing the web, you want to open a website, you click on a link and nothing is happening. Just the spinner spinning in your Google Chrome or your Safari or whichever browser of your choice you are using, and nothing is happening. More often than not, you will just close the page because it's frustrating. We are living in an era of really wide bandwidth internet connection. We are familiar with speeds like 100 Mbps, 200 Mbps, megabits per second, and we are expecting for our website surfing experience to be fast and responsive. So we will not wait for long. Like maybe you will wait if it's like your company website and you need to submit something for your work. But that's another special case. Usually when you are just surfing the web, and for example, you want to buy something on a website, you are searching, I don't know, for maybe new pen for your kitchen. And when the website is not opening, you will just switch to its competitor and buy your frying pan there and never think about this first laggy and not loading website at all. Actually, 80% of the users will not even return to the website after they had a previous bad experience with it. So more often than not, in the future, you will be buying your frying pans and all your cutlery from the competitor's website, and you will not even try to go to this laggy and slow website again. And what is even more damaging to their business is that 32% of customers will actually tell others about their negative experience, possibly causing them to never go to this first laggy, slow website again. So as you probably know, when we are studying sociology, we usually do not share our positive experience. We are much more likely to share our negative experience. Like if you went to a restaurant and everything was just fine, like it was not a 5-star Michelin restaurant that you have spent a fortune on, it was just a nice evening. I don't think that you will tell every one of your friends about it. Like, yeah, it was nice. But if you go to a restaurant and it was sadly a very bad evening. Like the service was slow, the service was bad, the food was untasty, or something bad happened. For example, there were some very loud people at the table near you, or something else just ruined your evening. You are much more likely to tell your family, to tell your close one, tell your friends that, hey, I had such an awful evening at this like XXX restaurant. And then you will describe it because you were much more emotionally impacted by this negative experience, so you want to share it. The same happens on the World Wide Web. For example, when you are asked to leave a feedback, I suppose it has happened a lot to you when you are navigating a website or using an application on your phone, and there is this pop-up appearing. Hey, it would seem you are enjoying our application. Could you please rate us, give us like 5 stars on Google Play or something? And usually we just close these pop-ups because they are annoying. So if either you are so enjoying this application, you're loving it so much that you will actually do these extra steps and write a review for them, but that's a very rare case. It's much more frequent for the person to not have such a great experience with an application, and then they will go and write a negative review. So if you go on Google Play and, for example, you will open reviews on some popular applications, for example, for Facebook, for Instagram, for TikTok, and so on, most of the reviews will actually be negative. because people are having some issues, they want to vent their frustration, and only then they will actually write a review, not when everything is just working as they expect. We're kind of expecting by now things to be working smoothly wherever we go. So customers are expecting high quality service as a norm nowadays. And when we are not a customer, but a developer, when we are not consuming a service, but providing it, we have to take this into account and understand that each and every issue we have in our website or in our application will usually result with lots of negative reviews, but when things are running smoothly, usually we will not get lots and lots of happy reviews. And that's why I suppose we have lots and lots of services which pay people to leave good reviews, but that's a topic for another day. So when things are going smoothly, even though we will not get these like positive reviews saying how awesome we are, we can actually see how good performance is impacting our business in other ways. For example, Amazon has conducted the studies and they have discovered that they receive a 1% increase in their revenue, in their whole revenue, for every 100 milliseconds of improvement when loading their website. So the faster their website is, the more people are buying, the smoother the experience is, the more purchases they are making. So even though you will not be getting flying reviews, just because everything is working well, usually you will be getting more money. And ultimately, that's what businesses are for. They are not for reviews, but they're in this for the money. And we, as developers, are there to help the businesses make more money, to make their business more profitable so that they can develop it more and possibly give back to society when businesses are going well. So let's talk about different ways to improve website responsiveness. Performance is also, it can be mentioned as responsiveness, because when everything is loading smoothly and loading quickly, then your website is responsive to you. So there are 5 ways. We can reduce the number of HTTP requests. We can compress our files so that they weigh less and they are more easily loaded. Then we can optimize our cache. We can minify our code. And there is specific topic of image optimization in particular, because images are not the same as other files. So let's dig into this and talk about each of these ways in more detail. Reducing HTTP requests. So when you are loading a web page, your browser has to open a separate TCP connection. Remember, on previous lectures, we started that there are several layers when you are sending a request. Last lecture, we were studying AJAX, asynchronous JavaScript. And when we are communicating client with the server, when we are sending requests and receiving requests, as we have been doing at our previous lecture using Postman, we were only working with the outermost layer, with application layer, AJAX layer. We were just sending and receiving requests. But maybe you remember we had a slide explaining that underneath our application layer, there's also a TCP connection layer, connection protocol. Then we have IP layer, and it's the closest one to hardware. And even though we are not working with these layers directly, as front-end developers, we are usually working only with outermost application layer. Everything is still happening underneath. And when you are working with browser, we already know that JavaScript needs some environment to be run in. It can run, for example, in your browser, or it can be run in the Node environment. So JavaScript is heavily leveraging the browser engine. And different browsers have different engines. And exactly by leveraging the browser engine, by leveraging the web APIs, JavaScript is handling all the asynchronous code, as we have learned during our previous studies. So what is the problem in leveraging the browser's engine. The problem is that there is a limit to a number of concurrent connections, the connections we are making at the same time, that a browser can open to a single host. And when we were studying URLs, we learned that the host is like the base URL. For example, you are working with Amazon and you are sending requests to Amazon servers to get the data to be displayed in your client when you are surfing the Amazon website. So you are still hitting the single host. All requests will be coming from Amazon. And there is a limit to the number of connections you can have at the same time. This limit exists for a reason. It is there to protect a server from being overloaded with a high number of HTTP requests. Because when server is being bombarded by lots and lots and lots and lots of requests, it can even be used maliciously as a DDoS attack. Maybe you've heard about those. It's when the hackers are sending an enormous number of requests to the server in a short amount of time. They are artificially creating these requests, sending them to the server, and then the server crashes because it cannot handle these requests. And from time to time, some websites, they become the target of DDoS attack. So maybe you've heard about such occurrences in the news. So to prevent this from happening from the regular user's behavior, we have this limit that one user, like one client, one browser, cannot send lots and lots of requests simultaneously. For example, for Google Chrome, the number of such concurrent requests is only 6. And when there are more than 6 requests being sent simultaneously by the client, we are not actually working with them. Instead, we are sending the first 6 and we queue other requests to be sent later, like we are serving the client in the batches of 6, if we are talking about Google Chrome. So obviously, when there is more than 6 concurrent requests, the loading time will be much slower because you have to wait for the first 6 requests to be run. And then as like these slots get free again, they become unoccupied, then we can send more requests. So we are working in the batches of 6. Let's see how we can optimize this.
Also, I have a question that the limit concurrent, if the reason why is, I say some DDoS attack, the hacker use many computer, right? Because
Yes,
the
they are
limits like
using special software. Yes, they're using special software, which I don't think I shall be teaching you this, but anyway, which is using special software to like emulate lots and lots of clients. And then all of these clients are sending the maximum number of requests, and there are lots and lots and lots of clients artificially created. And then the server crashes. Usually this is not being done by one person, but lots of people who are all running these artificial clients on their machines. Like maybe, there are lots of anonymous boards in the internet. They're called like 4chan, for example. And there are lots of people who just take strange pleasure in crashing various websites. So they do this frequently. And this can also be done like for political reasons, economical reasons, but maybe you have also seen how websites are preventing such attacks, because like those attacks are quite frequent nowadays, sadly, because I think that the web shall be accessible to all. And maybe you have encountered such things that when you are going to a website, it just tells you, could you please wait a moment? This is DDoS protection. Like we're checking that you're an actual client. Please wait for 2 seconds. You're seeing a spinner and then the website loads. This is anti-DDoS protection. Like instead of actually sending your request, first the website is checking that you are an actual person, you are not part of a malicious software, and then it displays the website to you. So nowadays many sites are using this to not be crashed with DDoS attacks, because obviously this is very bad for business.
Okay.
Yeah. So this anti-DDoS software is also a good measure if, for example, your client is hosting some news network, or you think that the risk of being targeted by DDoS is high. But let's think about positive scenario. No one is targeting us with DDoS attacks. We are just living our peaceful lives on our server, but still we would like to improve the experience of our end users. So what we can do is to reduce the number of our files. On the left, we can see that we have, without optimization, 19 files. We have 16 images, we have 2 CSS files, and 1 HTML file. So, as we have learned, our Google Chrome browser can only open 6 TCP connections to the server at once, so the browser will have to queue the remaining 13 requests. This will result in a quite long waiting time for our end user. However, we can consolidate all of our template images into what is called a single sprite image. It's when we are consolidating all the image files and we have only one sprite image file, and then on the client we will be using parts of this image when rendering. So instead of 16 image files, we will have only one, and this will reduce the number of requests we are making from 19 to just 4. Not only does this let Chrome parse the page in one sitting without adding the request to the queue, but it reduces the number of round trips needed to load the page. So maybe you have seen such things happening. You are navigating to some website on World Wide Web, and then you can see the images slowly loading, and as images are loading, they are pushing other content down. So the image you are seeing is kind of jumping around the page, like it is loading, then it's getting pushed down by other content, and usually it's not a very good viewing experience. It's really annoying. So when you are loading your image all at once as a sprite, all images will be at the client at the same time, and this will prevent such things from happening. So we have also talked briefly about CDNs, content delivery networks. They can further reduce server response time by actually pre-pulling connections and making certain that they remain open throughout a session. Pre-pulling means that we are anticipating that in the nearest future, the client will make a request. Like, for example, you have your logic written that on the first render, we have to load this HTML, this CSS, and these images. Like, CDN knows this, that on the first render, it will always load these files. So it can actually improve the time by not waiting for the client to actually send the request. This is really awesome. As we have tested in Postman, usually I am the client, who is responsible for opening the connection. Like, I send the request, I get the response. It's not like the server can send me anything if I didn't request it. Yes, so it's impossible for me to just wait without sending any request to the server, and then some information appears. But CDN, they make this possible. So they can pre-pull connections. So even though I, as the client, did not open the request for images, the CDN knows that I will do so like in a second. So it will pre-pull this request. It will open it for me. And then it will make sure that these requests remain open throughout the session. For example, we know that this website has lots and lots of images. Like, for example, you are browsing some clothes shop, or any shop on the web, really, some online store. There are lots and lots of product images. So we can set this connection for images to be open throughout your session, and it will allow us to load these images very, very quickly and efficiently. So while CDNs don't reduce the number of requests, pre-pooling improves performance because it eliminates delay times associated when closing and reopening these TCP connections. So we just know that we will have lots of such requests in the future, and we do not open and close the connection after each and every request. We just leave it open because we know that it will be frequently and widely used. It also shall be noted that HTTP protocol, which we have studied in our previous lecture, we have studied that there are such things as APIs, like the way how we can communicate with applications, its application interface. And we are nowadays on the World Wide Web, we are mostly using the RESTful API. And RESTful API, to which I have sent you links after the previous lecture, it is using HTTP. And we have learned how to send GET requests, POST requests, PUT requests, delete requests, and so on and so forth. These are all HTTP requests. But as with every technology, HTTP also has protocols of their own. So HTTP is also not static, it's developing. It's becoming better, and nowadays there is a very nice new version. It's called HTTP2. HTTP2 protocol. I will link an article to the chat about it. So the main takeaways, the main changes that have been done to HTTP2, this new version of HTTP, it introduced what is called a multiplexing. It's a connection method that permits multiple requests and responses to be sent via a single TCP connection. As we have studied just now, Google Chrome, the browser, it can only have 6 TCP connections to the same host open at the same time. And previously with HTTP1, HTTP 1.5, one TCP connection meant one request being sent at the same time, like 6 TCP connections meant 6 requests. And this new HTTP2 protocol, it introduces multiplexing. So these 6 TCP connections, they can handle more than 6 requests. Now, HTTP connection permits to use multiple requests and responses to be sent via it. It's extremely useful because now everything will load quicker. We are no longer hard boxed into this, like 6 TCP connections means 6 requests being sent at the same time. But it shall be noted that not everything on the World Wide Web is using HTTP2 nowadays, but it will become more and more widely used in the nearest future, and that's really awesome news. It does not mean that we shall stop with optimization, because when we are doing this, our load times are still getting quicker, they're getting lower, and that improves our website performance. But HTTP2 protocol is very good news for us. Next, I would like to talk with you about the file compression. So, what is file compression? When we are loading files, we are usually loading lots and lots of different data, like each and every one on the website pages nowadays, they are built from a collection of HTML, JavaScript, CSS, and maybe other code files. For example, there are some documents you would want your customers to download from your site, and so on and so forth. The more complex the page, the larger the code files, and the longer the load time. And with file compression, these files can be shrunk to a fraction of their original size to improve the performance. Sorry, I had to mute to cough because I'm still having a bit of the cold, so sorry for that. Maybe I will be muting from time to time during this lecture. Sorry in advance for that. So, by using file compression, we can shrink these files, and thus we will greatly improve site responsiveness. And the gzip format is widely preferred for its quick encoding and decoding times and high compression rates, which you can see on this site, like we have the comparison table. Oh, one moment, I can see there is a message in the chat. Oh, thank you for saying it's okay. I'll try to do my best, and thank you for your patience. So, the gzip format is nowadays the most popular file compression choice. It can shrink a code file by as much as 60 or even 80%, so it drastically improves the performance. Of course, it shall be noted that when you are gzipping something, when you are compressing your file, first you have to compress it. It takes some time. And then and I'm back. I suppose I disconnected for a second, which is very strange because I'm using my office Wi-Fi. But well, strange things happen. So when did you stop hearing me? I was talking about gzip compression. So when did the connection get lost? Can you hear me now? Is the connection okay?
Yeah, I can hear you.
That's awesome. Thank you. Because this connection server scared me a bit first time this is happening. Quite strange. So we were talking about gzip and that it can shrink the code file by 60 or even 80%. Good news for us is that nearly all content delivery networks, CDNs, provide automated file compression. So you do not have to do this manually. CDN will do it for you, gzipping all compressive code files, for example, CSS and GS files, before serving them to website visitors. Important thing to note is that gzipping is not effective in reducing image file size. So we will talk about images later in more detail in another section of this presentation. So I suppose you are already using compression in your everyday lives, like maybe you know about WinRAR or about 7-zip. So I suppose you have zipped, as it's called, your doc files when you are sending them to your friends or when you are sending them to your university. So compression of the files, it drastically improved how we can transfer data in the World Wide Web. And the best news of all is that when using CDNs, you do not have to do it manually. They will do it for your website. And that's awesome. But obviously, you can still be choosing the format. You can still like fine tune this file compression. But please don't worry. In your first projects, your senior colleagues will be actually responsible for fine-tuning the optimization of your website, and you shall just be aware of such thing as file compression exists, what it does, and why it is useful. So, before we talk about images, let's first talk about cache optimization. So, HTTP cache headers, when we are sending the request, it also has headers. These headers play an important role in the way browsers parse a website because these headers determine which content items are cached and for how long. So, what caching is? Caching means storing your static files. Usually they are the largest files we have outside of your server, either on visitors' local drives or a nearby CDN PLP. So this can vastly improve your website's load speed. For example, when you are surfing the web and you are using a VPN to access the content which is not accessible from your location, for example. I'm originally from Russia, so I'm quite familiar with that. And when you are using VPN, on the right side, it gives you access to the resource you would not have access otherwise. But I suppose you have noticed that when using VPN, your internet connection, it gets slower. Like everything feels less responsive. Why is that? Well, World Wide Web actually is lots and lots of cables. They're like transatlantic cables, there are cables which are underground, and we are still mostly using the actual cables. Like the new innovations such as Starlink proposed by Elon Musk, they are not widely adopted yet at all. They're still experiments. So when you are sending a request to your website, it is not going to your website directly. First, it's going to such thing as DNS. You can think of it as a phone book of World Wide Web. And then your Amazon.com, it gets changed to a string of numbers because each and every website has a unique IP address, a unique identifier. Then this IP address, it is being searched across several servers. Then we are finding it at the closest server, and then you have your connection open to your website and it begins loading. Usually this is quite quick, and as an end user, you don't even have to know that such things are happening behind the stages. But still, uh, let me just link you another article about what is DNS and how DNS works, because this is quite useful for our front-end developers so that we can understand better how everything is working. Oh, and I suppose I did not mention it, DNS means domain name system. So your path from end user to origin server, it can be quite long. There are lots of stages it shall go through. So all this takes time. And when we are using caching, when we are storing this information not on the origin server, but like closer to you based on your location. So when you are connected to your network, for example, when you are trying to measure your internet connection speed, it is usually measuring your speed against your nearest server. So, for example, there is such a speed test. It's called UCLA. And when you are measuring your performance with it, you will see that it will tell you, like, I was measuring your speed against this server. So if you are in Vietnam, it will not measure you against the server which is based in Munich, unless you specifically tell it so. It will measure your speed against the nearest server. So by using caching, we are storing our static files outside of our server, because our server, it can be, for example, in Amazon Cloud Server somewhere in the USA. But I am serving client from Vietnam, and traveling, if my data is traveling such a long distance via all of these cables, then it will result in a long waiting time, for example, several hundreds of milliseconds. But we can cache, we can like store a copy of our static files closer to our end users. So lots and lots of very popular websites which are used worldwide, they do not store their data in one place. So they usually have like the single source of truth, their origin server. Like if we push a new code to the code base, to example, code base of Amazon.com, then we will push it to the origin server. Like we will change it in one place, and then it will have to be cached, its copies will have to be created and cached closer to our end users all over the world. And this will result to faster response times to our users because this data is being physically stored closer to them. So the only downside to caching is that when you are doing it manually, it can be very tedious and inefficient. And moreover, caching mechanisms only often run into issues when handling dynamically generated content on the fly. So for example, Ajax objects, which we have studied before, they are usually constructed on the fly. Like you do not know what the object will be until it is being sent. Like for example, I'm sending a post request, like to create an order for my book, as we have been doing in our previous lecture. I cannot pre-cache this response because I do not know what ID of the order is yet. I have to first get this information. So caching first was for only statically generated files which are not changing, but nowadays CDNs offer us cache control options which allow us to actually cache Ajax objects and even dynamically generated HTML files. So CDNs usually do this by offering administrators user-friendly dashboards, so it provides you with administration interface. And with this dashboard, CDNs allow you to set site-wide policies. So what a policy means? It means how we will manage their caching rules for individual items, or even set policies from this dashboard for entire file groups. And we can base these rules on things such as file type and location. For example, we can set on the CDN cache control dashboard a rule saying that always cache all images in the block folder for 60 days. So it will be very easy for our user to access this in the future. So at first they will pull it from the origin server, then we will cache it closer to them, and all subsequent requests will be faster. CDNs have also begun integrating machine learning techniques, which are quite popular nowadays. And these techniques follow content usage patterns, like as an end user, what I'm doing on this website, which pages I'm visiting most frequently, which resource I'm loading most often. So we can construct based on my behavior the usage pattern to automatically optimize caching policies. And we can cache the typically uncacheable dynamic content. And CDNs, they relieve us of nearly all cache management tasks, which is awesome, because handling all of this manually for different regions, for hundreds, thousands, or nowadays popular websites and applications have like millions of daily users, this is unfeasible. And CDNs, they allow us to manage caching in much more approachable way. So this is awesome. Next, image optimization. So caching and compression are the two most common optimization methods, and caching is usually the most effective. Unlike code files, all image formats are already compressed. And as a result, to further reduce image file size, you have to tamper with that image data, either by removing some of the header information or by reducing the original image quality. So this is known as lossy compression, lossy from loss, losing something. So it shall be noted that while actually discarding data and diminishing resolution is often unadvised, lossy compression can be really useful for some high resolution images. Because, for example, if you are interested in photography, you know that when you are taking a really high resolution photo of something, the size of this image can reach several megabytes. Like there are images which are 10, 20, 40 megabytes, and you can zoom in, and the image quality will still stay very high. This is awesome when you're working with photos, but this is not so awesome when you are surfing the web. Because usually we are surfing with the web on like zoom equals 100%, the default one. Or maybe if your eyesight is not as good, or for example, it's your grandmother or grandfather surfing the web, they may set their zoom size to like 150 or 200% at most, because if you set zoom more than 200%, most websites just don't display properly. Like when we are talking about making our websites accessible, we are bound by various conventions such as W3C for accessible internet, and it means one of its clauses is supporting websites on zoom levels up to 200%, but no more. But still, usually you will not be seeing your websites in extremely high zoom level. So you actually don't need to see this very high resolution image. It will just mean that to load this image, which is very heavy, it's very high quality, but it weighs like several megabytes, and it will take us some time. So we can actually use this lossy compression to maybe reduce the image quality, but it will not be noticeable to our image users. But our end users will notice that our website is responsive and it is loading quickly. So CDNs are again coming to our rescue, and they are usually the go-to solution for image caching, because we can also store images closer to our users. And furthermore, some CDNs can also help even automate the process of image compression, letting you as administrator choose between page load speed and image quality. And more advanced CDNs also offer what is called a progressive rendering option, putting a twist on the original lossy compression concept. When you are using progressive rendering, the CDN quickly loads a pixelated version on the image. Maybe you have seen this already while surfing the web. The image is already present, but it's a very bad quality, it's pixelated. But then, extremely quickly, CDN begins progressively replace it with a series of better and better looking variants until the actual image is ready to load. Like instead of loading one image, you are loading lots and lots of images starting from very low quality. It will be loaded first and already displayed to a user. And then very quickly you will be loading more and more images, each of more higher quality than the previous one. So progressive rendering is useful for its ability to diminish perceived load time without sacrificing image quality, but obviously it uses up much more data, because instead of one image, our client is actually downloading several images in a row from low quality to high quality. So it shall be used in moderation. Like, for example, if your website is mostly used from mobile devices, in majority of countries, our mobile plans, they do not support the unlimited internet. Like, for example, I'm living in Armenia, and here we actually have unlimited mobile internet, and it's still like a miracle to me because I have never experienced it before, and it's really awesome. But in the vast majority of countries, we have what is called data plans, which means how much data we can actually upload or download using our mobile device in a month. So progressive rendering can really harm our data plan by making us spend our data very quickly. So it shall be used mostly for websites which are accessed from the desktop, because for desktop internet connection nowadays in vast majority of countries it is unlimited. You're only paying for higher speed connection or lower speed connection, not the amount of data itself you are downloading when you are using your home Wi-Fi or cable. So let's quickly go through the benefits of image optimization. Reduced bounce rates. So this is what I have explained before. When you are going to your website, it is loading and every content is like bouncing around because images are being slowly loaded, and then the image has loaded above. Like, for example, the website is long and you start scrolling down, trying to see the content, but in the very beginning of the website, there were several images. They just did not load yet. There is only text. And then as you are scrolling, these images begin loading and they are pushing your text down, and it's very annoying. So image optimization reduced this behavior, this bounce. Improved customer engagement. Nowadays, images are vital to to our websites, because maybe in the very beginning, like in the first websites, like the CERN website, the very first website on World Wide Web, the website were mostly in text format. But nowadays we are much more familiar with seeing images. We see them in articles, and in most of popular applications, we are mostly relying on images and not on text. For example, what is Instagram without images? It will be like unusable. What is TikTok without videos? If it's just only text, again, it's unusable, and so on and so forth. So by running image optimization, and also like if we're talking about TikTok and other such applications, video optimization also exists, and it's very popular optimization technique. We will just not be talking about it in detail in this lecture, because videos are less frequently used than images on our website. Also, when you are optimizing your images, it means cost saving. So if your images weigh less, then you are sending less data. And improved search rankings, because page load time and performance are a ranking factor on Google and other search engines. If your images are optimized, Google search engine will give you a higher rating, and your website will be much more likely to appear higher in the search queue. And it is extremely important for the business. Like, for example, when you are searching for something and you are not searching for a particular website, but you are just like, buy a frying pan. Where can I buy a frying pan? Like, for example, in Yerevan, where I'm currently. So if you are inputting such a query to Google, most of the time you will select a website from the first page of Google. It's extremely rare that we will actually go to second, or God forbid, like the third and fourth page of Google search results. Same goes for other search engines. We as end users usually value our time and convenience above all. So if your website is lost somewhere down the line in the Google search results, it will drastically reduce the number of user interactions with your applications. So that's why lots and lots of websites are actually like paying money to search engines to improve their position on this. I suppose you have seen that when you're searching something in Google or in other search engines, first several rows will be like ad, advertisement, and they will be displayed above all other search results. And there are also ways to improve your ranking with HTML optimization. We will also talk about it today. So on this next slide, I would like to give you an example of image compression. So on the left, we can see image of this adorable panda before compression, and it weighs 72 kilobytes. And after compression, the same image on the right weighs like 14 kilobytes. So if you study the images closely, you can see that, for example, the fur, the individual hairs of the panda, especially when we see the black fur on its arm and the white fur on its body. On the left image, it is much more detailed, and on the right image, it's a bit more fuzzy. And then it becomes a question of whether this image on your website will be of large size or small size. If this panda is about to be used like as a background, or it will be a very big image, or it will be used in a header of your website and it will be like a brand image, then I suppose you shall be using a more sharp resolution. But if this is a very small image, for example, this is an article link that will then link you to an article about pandas, and this image will be like 100 pixels in width on your website. Then I suppose you do not need a very high resolution, and your panda will be happy with 14 kilobytes. And your website performance will further increase because of that. Another image optimization technique, which is very important, is to replace some of your regular, or as they're called, raster images with their vector counterparts. So raster images are the images we are all familiar with, like this panda is raster. If we are zooming in this image, then this panda becomes more and more fuzzy. And vector images, they are actually being created using actual lines. They are not the images, they are equations, which let me again send you a good articles. So here's a good article about vector versus raster graphics, which tells you about this difference in more detail. So raster images are images we are all familiar with, like JPG format, PNG format, and so on and so forth. And vector images, they are written logically, like instead of having an image of this rocket, and if I magnify it, we can see that it becomes pixelized. On the other hand, vector graphic, it actually supports each and every resolution, because instead of painting this rocket, I have like the logic behind it, like, hey, it is comprised of these lines. They shall have these shapes, and then they are filled with such and such colors. So these images, no matter how big or how small they are, they will remain the same, because these lines and the colors inside them, they will just be redrawn. So vector images, even though they are not useful for example, photos, yes, like this panda, it has way too many details to become a vector image. But this rocket, which is very simple, like you can see that, hey, it has a simple white shape, it has three red fins, it has a very simple background with clouds, and so on and so forth. So these images, they can be replaced with vector images. I suppose this is not a manual process, like it shall be done by designers. And when you receive this vector image, it allows you to use these small images. You can see that in my example, the vector graphic actually weighs smaller than the rest of one. It only weighs 5 kilobytes, and it's applicable to any resolution, because instead of pixels, we just have an image composed of simple geometric shapes. So this is a very good way to improve your website, especially if you are using some graphics, not photos, but graphics. So this is more like on the product team and designers, but as a developer, you can also in the future suggest to your design team, like, hey, we have this simple graphics image, and I suppose it will be very nice if we could convert it to vector format and use it as such. It will be of less weight, and it will be applicable to each and every other resolution. So here is the comparison of different image formats. There are lots and lots of them. So there are the JPEG format, the PNG format, and there are also TIFFs, GIFs, and vector graphics are usually stored in EPS. So I have included this site mostly for your future usage. So you can analyze this and see that, for example, hey, if I'm using the PNG graphics, I suppose it will be better to use like in web applications, PowerPoint, Keynote presentations. And if I'm using TIFF images are of very high quality. TIFF format is mostly used for print. So if you are trying to order a t-shirt with a very nice custom print, it will usually be stored in the Web Studio in TIFF format so that it can be printed in really high quality for you. And vector graphics, as I have mentioned before, they can be, because of supporting each and every resolution, they can also be easily used for print materials and on lots and lots of websites. In short, vector graphics are awesome. Next, we can actually encode our images. There is such algorithm which is called base64, and it's an encoding algorithm which converts any characters, binary data, or even images and sound files into a readable string. So we can actually convert almost all data formats to a string, which can be saved and transported over the network. The amazing thing about base64 algorithm is that this conversion to string and back to the original data format is not a lossy conversion. It is done without data loss. And so base64 images I primarily use to embed image data within other formats like HTML, CSS, and JSON. So again, by using base64 image encoding, you can input this string as part of your CSS or HTML file, again, reducing the number of files that your browser has to load. So it saves the number of HTTP requests, but you should only use this in documents which are heavily cached. So because you are adding these strings, and with base64 encoding, these strings tend to be quite long, these encoded strings, on one hand, it saves HTTP request number, but on the other hand, it actually increases the weight of these files. So if you are not caching this data, then base64 image encoding may not be the best way. And base64 is very easy to convert online. For example, there is a very popular website. It's called base64 decode, and here you can actually try doing it yourself. You can decode and encode anything. Base64 is an amazing algorithm. So, what are the cons of using it? As I already told you, the size, and it's hard to maintain site with embedded data you use for everything. Because when you are seeing these encoded images, it's very hard to understand without decoding them, what this file actually is. You have to decode it to actually see it during development. So encoding something with base64 is mostly useful when your data is static. It is not expected to change very frequently. Otherwise, you will be doing quite good with just image compression and smartly choosing the format of your data to be used. And again, vector graphics are awesome. I suppose the last advice that I would like to give you about the images is the less the amount of images you are using, the better. So we shall not be using images if we can do without them. What are good use cases for not using images? For example, headlines. Even if your headline is written with some very beautiful font, you shall still be using the font and not just copying it as an image. So that's why we have lots and lots of beautiful fonts on the web, and you can buy them and you can use them on various websites. Also, because images, something bad can happen to them and they cannot load at all. For example, if there is some upstream error or your image is degraded or something happened to it and it did not load. Images not loading happens much more frequently than text not loading. Because if your website even lost all of its styles, the text, the HTML contents, will still be available to your end user. So, good piece of advice is to avoid placing contact information other important information directly into images, because if it does not load, then your end user will not have the ability to access this information at all. And CSS is a very powerful tool which allows us to create styles that previously required images. Like, for example, nowadays with CSS, we can create complex gradients. Like previously, if you wanted to have an amazing background, which is, for example, pink on the one side and green on the other side with nice slow transition, previously you had to use images for that. But nowadays, CSS supports this. So you can make do without images. Also, CSS currently supports shadows, it supports border radius when you want to make rounded corners, and so on and so forth. So if you can do this with CSS, if you can do this with HTML, please do not use images. It is the best way to improve your website performance. So here is how we are optimizing our images, like our main checklist. First, thanks to CDN, we will try to automate as much as we can of our image optimization process. Next, we want to minify and compress the images in SVG format. Then we want to pick the best raster image format for our situation, like EMG, PNG, and so on and so forth. Then we want to remove unnecessary image metadata. Each image, it has more than just a picture. If you analyze its metadata, you can see where the image has been taken, by which camera it has been taken, the data, sometimes even the location, and so on and so forth. Obviously, this metadata is useful, for example, to photographers when they are analyzing their photos, but it is not useful for the end user of our application, so it will be good to remove it to further reduce the image size. Then we want to serve the scaled images. If our panda on our website is supposed to be small, then we shall be loading the small image, not loading a very, very big panda and then telling it with styles to actually be very small. By doing so, we are unnecessarily increasing the panda file size. And the last but not the least, prefer vector formats, because again, vector images are awesome. So, what are the use cases for image optimization? As I've told before, CSS is amazing. Nowadays, CSS has so many awesome features that will allow you to do like proper magic. There are even nowadays games which are written only using CSS. There are even CSS artworks which are created only using the CSS. So, for example, here is some good articles on how to do CSS arts, like examples of what can actually be achieved by professional artists. And I strongly encourage you to look at it because it's very inspiring and allows you to create things which were previously like not possible at all and required raster graphics. But now CSS can do awesome things. And when it's possible, we shall be using fonts instead of text encoded in your images. And most importantly, use different image sizes for the devices you want to target. For example, when you are serving images to your client, you can see what their resolution are. So when your end user is viewing your website from, for example, very high resolution wide monitor, and their resolution is like 2400p, then your images shall be of high quality. Or, for example, when your end users are using Mac, Mac support a special technology called Retina on their displays. And for Retina, each pixel actually contains 4 pixels. So Retina displays are even much more dense in pixels, and if you see that it is a retina display and we can see this using the user agent, then we can and should use higher quality images. On the other hand, if your end user is reaching your application via their smartphone, you can again see this via the media queries. This is how we are doing our responsive web design, like your application shall be looking good both from desktop, from tablet, from mobile devices, and mobile devices, they do not need such high quality, such high resolution images as retina displays, super wide displays do. So it is also a very good idea to have several images of several sizes to be loaded based on the user agent, based on media queries, this will allow your end users to have good experience, because none of us want to see these pixelized bad quality images on our very expensive display. But if your end user approaches your site using their mobile phone, their website will load even quicker, they will spend more data, and they do not need such high quality images because their display size is that much lesser. Next, critical rendering path optimization. We have talked briefly about CRP, critical rendering path, during our previous lectures when we were talking about DOM and the BOM. But now I suppose it's the time to get into more details. So CRP is the process your browser goes through to convert the code into displayable pixels on your screen. CRP has several stages, some of which could be performed in parallel to save time, but some parts have to be done consequentially. Let's go through it step by step. First of all, once the browser gets the response, it starts parsing it. And when it encounters a dependency, it tries to download it. So when you are navigating to this website for the first time, first render will occur. So we are sending the GET HTTP request to the server, and then we are receiving HTML data. Because both for MPA, multiple page applications, and SPA, single page applications, first request will still be filled with HTML. So we receive this HTML document, and then we know that in HTML we can link CSS files and we can link images, we can link our JavaScript using the script tag. This is what is called dependencies. And first we start parsing our HTML file. And because all nodes, they have opening and closing tag, it's very easy to parse it gradually and still end with a complete hierarchy of our nodes. And by parsing HTML, we will build the DOM, which we have studied previously, the document object model. And while our browser is parsing our HTML response and building the document object model, for example, we have encountered a dependency. We have seen the styles dependency. We have seen the link type style sheet in our HTML. So the browser will have to parse CSS completely before rendering the page as compared to the DOM. And CSS, because of that, is said to be render blocking. Why is that? When you are parsing HTML, you don't have to load all of the data before you can build the DOM. Like you have the opening tag, like for example, I have the P tag, inside of it I have span tag, inside of it I have like input tag, and so on. Yeah. So this is what I see in the moment. Like I did not load the page yet. I have just posted this to the chat. But still, even from this, I can already begin building my document object model. Like I can see that there is P, then inside of it, there is span, and inside of it, there is input. And Then after I have received the closing tags, then I can begin working on the next branch of the document object model. So when you are building the DOM, it is non-blocking. You can do it separately, branch by branch. And this is really awesome. It allows browser to see the code in part and begin building it. So for example, I have linked this image to the chat. We see at first, uh, let's see how this code was looking like when it was just like HTML before being converted to this document object model. First, we have the first tag, the document. So we open it, then we see the HTML opening tag. Okay, we know that HTML is inside the document. Then we see the head tag. Inside of its style, and then we see the closing tags. Okay, we know that there is only style tag inside the head and there is nothing else. So we return and then we see, hey, next we loaded the body, and inside the body we already see the Dean opening tag, and inside of it we see the UL, the annotated list tag, and inside of it, still not having encountered any closing text in this branch, we see the H2, the list, and only after we have passed all the lists, we see the closing tags and see, hey, the list has ended. It has this H2 and 4 lists. Let's go to another branch, and then we see the script, and then we see another unordered list, and so on and so forth. So we are able to parse HTML into document object model step by step. We do not have to actually pass it, like first load it all at once and then parse it. But this is not the same for the CSS model, as it's called, CSS object model. Why is that? So CSS, as it is derived from the name, are cascading style sheets. So here's another image explaining the differences. For CSS, we have studied previously such term as specificity. And that means that each element, it can have lots and lots of styles attached to it. Like in your CSS file, for example, you can have something targeting all elements inside the body. Like you can write it like so, body. Example, you want all your text on all your website to be black, and you will do it body color black. But then you says, hey, for all elements with tag P, I actually want my color to be green, for example. So all text in P colors will be green. You do not have to delete your CSS code for the body. P, because it's a tag, it will have the higher specificity and it will override your black color. Now all P tags will have their text green. And then you can increase this specificity. For example, when you have the with CSS class and you tell that, hey, I want all paragraphs, like my tags with paragraph CSS class, I want them to have blue text. And this again will rewrite it. And finally, you say that, hey, I want this thing with ID, with such and such ID to have color red, and it will again be auto-written. So CSS, because it's cascading style sheets, it means that all your styles are being written and auto-written and auto-written, and until you have gotten to the very end of the line and have written and passed all your CSS, all your styles, you actually do not know what the color of the text will be. Will it be black, green, blue, red? Maybe there is something else later down in my files, because actually there can be some inline styles and they will again override this to orange, for example. So in order to correctly parse CSS and build from it CSSOM, CSS object model, you shall actually load everything first and then parse it all at once. And that's why CSS is said to be render blocking. So while your browser is loading CSS, it is not doing anything else. It's just loading and parsing CSS. Then there is another type of dependency apart from our styles script dependency, our JavaScript. So if it's a script, the browser has encountered as part of our HTML as its dependency, the browser has to stop parsing the document object model, download the script, and immediately run it. Only after that can the browser continue parsing our HTML, continue building our document object model. Because JavaScript programs, as we know, can alter the contents of the web page, HTML in particular. During our previous lectures, we have studied how JavaScript can add nodes to the browser, can remove nodes, can change the nodes, and so on and so forth. So first we have to run the code, the JavaScript code, and then we shall resume our parsing. So for example, if we have encountered the code which is like, for example, P paragraph, and then we have actually the script, and inside of it we have some JavaScript code called console log. And then it is closed. And then we have another tag. For example, we have the h2 tag saying title. Here it is. I have posted it to the chat. If we encounter such piece of code, first we will parse the p tag. Then we have encountered the script dependency because we are adding JavaScript to our HTML as script tag. Then we stop parsing the document object model, we download the code, we run the code, and then we resume it. So JavaScript is also called parser blocking. Once all the parsing is done, everything has been loaded. We have the document object model, DOM, cascading style sheets, object model, CSSOM. And we have run all the JavaScript which was in between them. So then we have to combine them. By combining DOM and CSSOM together, we receive what is called the render tree. The non-displayed parts of the page don't make it into the render tree because it only contains the data necessary to draw the page. So for example, if you have some div block which has styles with display none, so it is not visible, it will not be rendered, so it will not become part of the render tree. That's why we need our styles. If we would render everything present in the DOM without taking styles in the account, we will spend our resources in vain for trying to render elements which will not be actually visible. So we are almost at the end of the CRP path. The penultimate step is to translate the render tree into actual layout. This stage is also called reflow. And that's where every portion of the render tree node, as well as its size, gets calculated. So each and every element on our page has some size. Like I know that I have the p tag. Inside of it, I have the text of such length. And this text, I know the styles applied to it. For example, it is 14p in size. Or it's a title. It's very big. It's 72p. And so I can see what the size will be, the size of this block. They are usually counted as just rectangles. So I'm building lots and lots of rectangles, just like laying out the base of how my page will look, like where things will be. I'm like drawing a plan. And After I have calculated where the elements will be displayed, it's time for the very last step, the paint. And it involves literally coloring the pixels according to data the browser has calculated during the previous stages. And after I have painted all my pixels, I can actually see everything on the page. A critical rendering path takes part very quickly, and as we have studied when we have been working with event loop, we remember that it manages tasks, micro tasks, and also the rendering. So critical rendering path, it's calculating and recalculating everything and then displaying new pixels, repainting pixels based on the frame rate of your monitor, usually 60 gigahertz. So this process is repeating and repeating again, especially the reflow and repaint. So render, layout, and paint, we are mostly interested for our optimization with reflows and repaints. These parts can be very expensive. They can hurt the user experience and make the UI appear sluggish. Like you do something and then instead of page being responsive, it begins like re-rendering and re-rendering stuff. So what can we do? The process of website performance optimization usually involves changes to the website that reduce one of three things: the amount of data that has to be transferred to our website during the first render, the number of resources the browser has to download, especially the blocking ones, and the length of CRP. Like we try to reduce the time it takes to go through all of stages of critical rendering path. So what triggers reflow and repaint? How can we optimize them? We will trigger reflow and repaint by adding, removing, or updating DOM nodes, hiding DOM node with display none or visibility hidden, moving, animating DOM node on the page, tweaking style properties, like for example, if you hover on a button and its style changes, it means that you have triggered reflow and repaint and new pixels were being drawn on the screen, and now your button is not blue but bright blue because you are hovering onto it. And when you are resizing the window, changing the font size, their zoom, or scrolling, like in essence, each time the pixels on your screen change. Like each and every scroll, it triggers the reflow and repaint. First, we try to understand where you are on the page, which elements shall be visible to you, like in your viewport. For example, the website is quite long and you have to scroll through it. So first we understand your position on the page, which elements shall be visible. We calculate their position during the reflow, and then we trigger the repaint, which actually paints the pixels. So how can we minimize reflows and repaints? We can batch together the DOM changes and perform them not in the live DOM tree. So instead of handling DOM changes one by one, we can like bundle them together, do them not single one by one, but in batches, doing them together. You can use, for example, document fragment to hold these temporary changes. You can clone the node you're about to update, work on the copy. You can hide elements with display none, then make lots of changes, and then just restore restore it again with like a display block or something else. So this way you will have two reflows instead of like tens or hundreds. And also, we shall not be asking for computed styles excessively. If you need to work with a computed value, we shall take it once, cache it, save it, and then work with the local copy. So instead of continuously asking the DOM, like for example, the current position of the cursor or something else, you can store this value and then use it in several operations and then update it only as needed. Also, using absolute positioning makes element a child of the body in the render tree. So it won't affect too many other nodes when you change its styles. Absolute positioning means position absolute in CSS, and I suppose you have already used it a lot. It means that your element will not be part of the reflow process. When we are calculating where all the elements are, according to each other. So for example, if I have my paragraph, inside of it I have a title, and beside it I have an actual text. If I add an image in between them, it will push the text down, yes? But if I add an image with position absolute, it will just be displayed with no connection to my reflow. So position absolute is usually being used for some decorative stuff or for some backgrounds. It allows us to not calculate its position during the reflow. So let me link something useful again about position absolute. So yeah, for example, free code camp, because they usually have quite good calls. So here it is for future reference for you. And with that, let's go forward. How can we actually measure the performance? The first rule of optimizing the performance is measure first, optimize only as needed. Like, don't spend lots and lots of your time for optimizing each and every small step if it's actually not needed. First, measure how your website is performing, and if you see that the performance is not as good as it could be, if it's not in the green zone, then you can optimize. How we can measure it? Most browsers developer tools, again F12 or Shift Control C, it actually has a tab called Performance, and there you can actually measure the performance of your website. And I strongly advise for you to test this, go to some various websites, go to the Performance tab, and take some measurements. So when optimizing for the fastest initial first render, there are three events which we shall dedicate our attention to. First, paint, first, contentful paint, and first, meaningful paint. Here, paint means successful render of the page, the last stage in the critical rendering path. A few renders may happen one after another because browsers try to display something ASAP and update later. So when you are doing your first render, there may be like several subsequent renders. Besides the rendering time, there are other things to take into account. Most importantly, how many blocking resources are used, like CSS, like scripts, and how long it takes to download them. This information is also found in the Performance tab after the measurements are made. So, what are the performance optimization strategies? There are three of them. Minimizing the amount of data to be transferred over the wire. First of all, we shall remove all unused parts, such as unreachable functions in JavaScript. For example, if you have written a function and you have never called it in your code, then this function is not needed, actually. Yes, so it is dead code. So your code shall be free of such functions. It can be analyzed with static code analyzers such as SonarQube and other programs to tell you which parts of your code are not actually being run, which are dead weight, and you can safely delete them. Next, styles. Styles with selectors that never match any element. It's very easy, especially in huge programs, to have lots and lots of CSS code, and we know that it's cascading style sheets, so it's much harder to see which code is being used and which is not, because you will not see any errors. It's just that your text will be orange and not blue, and for example, you are no longer even using any blue text in your application, but this CSS code is still there. Again, there are static analyzers which can help you, and There are lots of bundlers which can be used for this, like when you have started like Webpack, when you have started Babel, when you have started Parcel, and other things we can use to optimize our applications to actually build them. We can see that we can delete this unused code both in CSS and HTML. And this in itself will reduce the amount of data. And of course, shall also remove all duplicates. This is especially useful for CSS. It's very easy to create duplicates there. Then I would recommend putting an automatic process of minification in place. There are lots of minifications which you can do when you are running your dev and prod build. We will talk about this in more detail later down the line when we will have the lecture about tools. It will be one lecture after the next. And here you will learn how to automatically minimize your code. So instead of lots and lots of JavaScript files, you will have one minimized JavaScript bundle, which will be cleared from all the dead code automatically. And same goes for CSS, because usually in your applications, you will not have one big CSS file. It's just not easy for development to have one very long CSS file. It's much easier to have several CSS files. They're much easier to work with. But when you are deploying your code to production, you don't want this code to be easily understandable. You want it to be performant. So your code is being minimized, and even no additional characters will be included. For example, white space characters in JavaScript. When you're writing your code, we are usually like putting empty lines. When we are writing if statements, we usually do not write them as a very long one line. We have like if, our braces, then what we are testing against, then we have the opening curly brace, and on another line we have the logic we have to run, and then on the next line we have our closing curly brace. When we are minifying our code, all of this gets deleted and we just have lots and lots and lots of especially long lines of JavaScript codes. They are not readable, but they do not need to be. They just need to be run on the server for our end users. And after this is done, what we are left with can be just text. It means that now, after we have minified everything, we can safely apply a compressing algorithm such as gzip, which we have studied previously. And finally, there is caching. We can again store our files, our gzipped static files, closer to the user. It will save a lot of time on subsequent visits. So when our user is approaching the page for the very first time, caching will not kick into effect. So the very first render will be slow, or at least slower as it could be. But on subsequent visits, caching will kick in to full effect and it will reduce the time. Next, what we can do is to reduce the total count of critical resources. Critical refers only to resource needed for the web page to render properly. So we can skip all the styles that are not involved in the process directly, and the scripts too. So this is actually called code splitting. For example, your user is navigating to your application, and first they will see like one page. You do not need to load the HTML or CSS for other pages. Or even better, your website is quite long, so the user will have to scroll down a lot to reach some additional information. And you actually don't need, like in the very first batch of your data, you do not need to have the HTML and CSS information for the text which is not visible on the screen, which is much later down the line. For example, when your user is navigating, again, Facebook or Instagram, it is not trying to load as the first render the data about like 20 posts. it will usually load the data about the post you are seeing right now and buffer posts, like one before and one after it. And as you are scrolling, it will be opening new TCP IP connections, or even having it optimized, having this TCP connection open, and then loading and loading and loading more posts as you're scrolling through. So you're scrolling, your data is being loaded and being constructed and painted on your page. And this allows for the first render to be much more quicker. And then the third is shortening the critical rendering path. The CRP length itself should be ported to the possible minimum. The approaches that we have discussed just previously will do that as well. What we can use as well, media queries. Media queries as attributes for the style tags will reduce the total count of resources that will have to be downloaded. Media query usually means that you are targeting specific width of the screen or height of the screen. So, for example, if you are navigating your page from the mobile device, then usually your navigation will not be displayed at all, and it will be hidden inside what is called like a burger button. Like these are three horizontal lines in the corner of your screen, and if you tap on them, then you will see the navigation. It is quite popular behavior. So again, on the first render, you do not have to actually load information about nodes inside the navigation menu. You will need them later. So media queries can help with that. Script tag attributes. There are two special attributes. They're called defer and async. Using them will prevent the corresponding scripts from blocking the parsing. When we have been talking about document object model before, we learned that building document object model is non-blocking, but building CSS and JavaScript, running JavaScript, is actually blocking. But these special tags, async and defer, they actually allow us to run JavaScript differently. So with async, it allows us to not block what we are doing with our script. So when you have async, then the browser will not stop passing the document object model. I will again link the article about async and defer. It shall be noted that async and defer, they can be quite dangerous. For example, you have a script, and inside of it, you have, like, for example, some event listener. And to put up an event listener, you have to actually get the document object model node, as we have studied in our previous lecture. So first you are running something like get element by ID, and then you are adding event listener to this element. If you have added async to your JavaScript, I'm trying to run this code already, but for example, the node you are searching for, the node you want to get by get element by ID, is not present yet in the DOM. It will be loaded later. So instead of running your code, you will actually experience an error. Defer is working a bit differently. So when you are running defer, it tells the browser not to wait for the script. So as we have studied today, first the browser will have to load the script, and then it will have to run the script. By telling defer, it will not block the page. The browser will continue to process the HTML and build the DOM. The script will just load in the background, but it will run only when DOM is fully built. So in this way, defer is safer than async. Choosing between defer and async is usually part of the complex optimization strategy, and it will be very useful for you to know about these two JavaScript attributes and how they can be used. They are very, very powerful, but they shall be used in moderation. Otherwise, you can experience errors like running JavaScript code, attempting to manipulate DOM nodes which are not yet present, which are not yet loaded. Next, HTML optimization. What we can do here. We can be using semantic tags, and we can also get rid of redundancies and inefficient of archaic structures. So when we are minifying our HTML, we can be collapsing white spaces, removing HTML comments like all commented code when you are building your application using model builders such as Webpack, such as Gulp. The all comments code is usually deleted, both from JavaScript and from HTML, and also attributes which are no longer used. Here is an example how we can be reducing this. So here, for example, I'm on the left, I have my script put in the beginning, and this is bad. As we have learned, script execution is blocking everything. And here we are not using async and defer. So on the right, I have put my script on the bottom, and it will not block things that I am using. Next, we have my styles. Now they will be in the beginning. The good rule of thumb is put your styles in the beginning and put your scripts in the end. And then in the middle, we have our code, our HTML. So what are actual examples how we can optimize our HTML? We can remove unnecessary attributes. For example, previously we had attributes like type text JavaScript or type text CSS. Nowadays we are not using them. Like when you are adding script tag, you do not need to add uh, type. It will still be run correctly. So you can just skip it. And we can minify HTML. Usually this is being done by Webpack and other tools we use for building our websites. Next, what we can do is optimize CSS. Let's talk about this in more detail. So when we are optimizing CSS, we are combining multiple CSS files. It's usually considered bad practice to use inline styles. And by now, I suppose you already understand why it is that like so, because when styles are inline, we're actually mixing up our HTML and CSS. And inline styles, they are not part of CSS files, they're part of HTML, and so they will rewrite our styles and it will not be optimized. So please don't use inline styles unless like absolutely necessary. There is no other way to go around it, but usually there is using their specificity. Prefer link or the imports. So this is how you are adding your CSS. We shall minify our style sheets. We shall simplify our selectors. And as we were talking previously, base 64 bitmap images, they are powerful, but shall be used only for static content and only when you are using caching heavily. So do not add them if you are not using these mechanics. And for Google, for Google DevTools, Chrome DevTools in the Performance tab and Developer Tools, they will actually give you page speed recommendations, and these are quite useful. So what are the use cases? Minifying CSS files. This is not being done by hand. This is usually being done like by Webpack. Concatenation. Usually CSS files are concatenated into a single file. This is again is usually done not by hand, but when you are running a production build using Webpack. Not blocking CSS. CSS files need to be non-blocking to prevent the DOM from taking time to load. This means that you are bundling together only the CSS files absolutely necessary for the first render, and then you are adding other CSS files for other pages and so on and so forth. So concatenating CSS in a single file means concatenating CSS files needed for the first render into a single file, not like the old styles for all of your application. This will block the DOM building for a long time and will not be a good user experience. The length of our CSS classes can have a slight impact on our HTML and CSS files, but this is usually minor, so Please do not pay this lots of attention. First of all, CSS classes shall be understandable by you and your colleagues. And if your CSS classes are like A, B, C, and just some strings of letters, and no one can understand what they're being applied to, it will negatively impact your developing experience, and it is not worth it to just reduce the number of symbols in your CSS classes. It can have a small impact, but it's very minor. And removing unused CSS, it is also usually done by Webpack when you are building your app for production. Next, the last topic is JavaScript optimization in more detail. So there are several challenges that can impact JavaScript performance. Poor quality event handling, unorganized code, too many dependencies, and inefficient iterations. What we can do to optimize our JavaScript? Batch the DOM changes, as we have talked about before. Learning the methods of asynchronous programming. Asynchronous programming is really key. As we have learned with event loop, our asynchronous code is non-blocking. So our tasks, especially tasks which take a long amount of time, we can put them on asynchronous path. Instead of putting them on the call stack, we can put them on the task queue, and they will be executed in the background. And then we will just reap the benefits of seeing their results. So asynchronous JavaScript is the key behind performance optimization. Obviously, we can use gzip for compressing our files. If possible, we shall utilize HTTP 2, which supports multiplexing, so we can handle more than one request and response on one TCP connection. We can use thing which is called lazy loading. This again means loading only the parts of our application that we need right now. And then we can load our JavaScript code as needed. This is especially prominent if you are using frameworks. For example, if you are using React in your application, you can make your components lazy components which will only be loaded when they are needed. They will not be loaded at the first run of your application, again saving you time. Restricting library dependencies. There are lots of memes in the internet that there is nothing which weighs more than your npm dependency. So when we are developing our applications, it usually means like adding more and more dependencies. You usually are at like a crossroad. You can do something yourself, or you can add some npm package which will actually do it for you. And sometimes it can be very tempting to take like the short path, the easy path, but each time you're adding new dependency, the size of your bundle is growing more and more. So I have linked the image in the chat, and usually, yeah, node models are like the hardest things you will ever encounter in your application. Node models is a special folder in which all your npm packet dependencies are being stored. And if you do not control it, if you are just adding and adding and adding more dependencies on the top, it will just go out of control and your application will weigh a lot more. And what's worse, you will create too many dependencies between them. So if something breaks, it will be very hard to debug. So we shall be using npm packages in moderation. Always weigh. You shall use this library, or it will be easier to just write a polyfill for it. If you need only a small part of this library, maybe it's better to just add your code by hand and not add this library as a whole, because it weighs a lot. So, use cases. We will try to only send the code the user needs, so we shall break up our JavaScript in what is critical and what is not. Model bundlers like Webpack support code splitting, and you will learn about Mobpack in subsequent lectures. Lazy loading is also very powerful. Caching code. JavaScript is also a very good target for caching, so It shall be used for all subsequent requests your user makes to your application. Minification, compressing, and removing unused code. I suppose you have already noticed that the recommendation rules for HTML, for CSS, and HTML, they're kind of very similar. Removing unused code, compressing everything, minifying everything, and using like lazy loading, using bundles, trying to load only what is absolutely necessary at this point in time so that your end user can receive the information he needs now at the shortest notice. And then asynchronously, you can be pulling the data that you anticipate he may need next. So, code splitting. Code splitting means that we can split large JavaScript payloads into batches. You can code split logically, or you can just split large bundles in part. We will learn more about code splitting in the Webpack lecture, because this is a complex topic in itself. So, what are the ways to load the third-party script efficiently? If you are adding some third-party logic in your application and it's slowing everything for your end users, you have several options to improve your performance. You can load the script using the async or defer special attributes, which we have studied today. We can also consider self-hosting the script. So if the script is crucial for your application, but the third-party server is very slow or it does not support caching or something like that, we can consider self-hosting the logic we need on our servers to make it easier for our end users. If this logic is actually not critical, we can consider removing the script altogether. And we can also consider resource hints like link-rel pre-connect or link-rel DNS prefetch, which will allow us to do a DNS domain name system lookup for domains hosting third-party scripts. As we have learned today, when you are connecting to a website, you are not actually sending the request to it directly. First, you are using a DNS, you are converting the name to IP address, then you are searching for this IP address, then it's being changed to name again, and then you're finally loading your web page. So by using pre-connect or DNS prefetch, it will allow you to shorten the time it takes for DNS to perform your request. Shorten in the eyes of the end user. You will just begin this process earlier. So to sum up our lecture, third-party script optimization should be followed by ongoing real-time performance monitoring. Usually huge applications have Grafana boards set up, Prometheus boards set up, which allow us to monitor the application health and performance in real time. So the web is evolving at a really rapid pace, and there's always something new appearing which can help us to improve our web performance more and more. This is actually amazing, and I'm very happy to be a web developer in 2022 because each month, each week, something new is getting its spotlight on the stage, and we can see how to make our applications faster and better. And with that, our lecture has come to an end. Do you have any questions? Okay.
I have a
Yes,
question that we do optimize before while we coding or after we coding.
when we are coding, we can use several optimization techniques. For example, we can consider how we will be splitting our JavaScript code, or we can delete unused JavaScript code, unused CSS. But mostly, optimization takes part after when we are shipping our code to production. That's when we are minifying our code, compressing our code, when we are using some other techniques such as caching. When you are working with images, the majority of work is being done during coding. For example, you are using media queries, you are writing logic to use smaller images for mobile, larger images for desktop, or you are making a choice to use, for example, vector graphics instead of raster graphics. But then again, when you are finished writing code and you are shipping your code to production, then after the coding is done, you are also gzipping your images and you can do image sprites, which reduces the number of TCP requests which shall be done to the server. So it's being done both when you're writing code and after you are finished writing code.
Yeah, okay, it's clear to me.
Okay, thank you for your question. Are there any other questions? Oh, sometimes my slides are not synced with yours. Uh-huh. I suppose there is a button which tells you go to present a slide. So it will allow you to jump to the slides that I'm currently displaying. So if you have changed the slides manually during the presentation, then you have to sync with me again. Okay. Are there any other questions, or can we finish this Monday lecture? Okay, I suppose there are no more questions left. Thank you very much for your attention, and I will see you again this Wednesday. We will have a lecture about ES next. So I'm wishing you an awesome Monday. Thank you for listening to me, and goodbye.
Uh, okay. Okay, bye.